Hi, question number 1. Find the roots of the equation z to the cube is equal to minus 108 root of 3 plus 108i in the form r into cos theta plus I sine theta, where r is greater than 0 and 0 less than theta less than 2 pi. Now the first thing I would do is I would try to find r, which is the modulus of the complex number z cube, and all of that's going to give us the square root of negative 108 root of 3 to the square plus 108 to the square. And if we were to find this on a calculator, it's going to give us 216. And now this next step in this is to find the argument of z to the cube. So which is this one here, and this is going to be theta, and we got the real axis where the point over here on the left hand side is negative 108 root of 3, and on top here I've got 108i. And of course the argument of z to the cube is going to be equal to all of that over here, which is pi, minus the tan inverse of 108 opposite, so 108 divided by 108 root of 3, which is basically 1 over root 3, and the tan inverse of that is pi upon 6. And now if we do that subtraction over here, we're going to get 5 pi over 6. That's the basic argument of z to the cube. And of course, we're going to be using the De Moivre theorem. So De Moivre theorem, which is z to the n is equal to, can I say, r into cos of theta plus I sine of theta. If I were to remove n and put it on the other side, okay, I'll get then z is equal to, let's say, r to the n, all of that to the n. Okay, so cos theta plus I sine of theta, all of that to the n. And so let's push this a little bit up over here. Now my basic angle here is theta is not this theta, this is something else. Okay, that's going to be the argument 5 upon 6. So what I have is then z to the cube is equal to 216 into cos of 5 over 6 pi plus any rotation of that angle 2k pi, all right, plus, and all of that in brackets, the I sine of 5 over 6 pi plus 2k pi, and of course that in bracket, and all of that over here. So I'm squeezing everything there, so maybe I can just try and do it somewhere here. So now I'm going to get z is equal to the cube root of 216, that's 216 to the power of 1/3. And if I were to look at my angle, all right, so the basic angle here is, what is the angle? It is 5.6 pi plus 2k pi. So we are looking at cube here. That means k is going to be equal to 0, 1, and then 2. Now for 0, my basic angle is going to be equal to, of course this is power 1/3. Okay, my basic angle here is 5 over 6 pi. So 5 over 6 pi, that's my first angle when k is equal to 0. So if k is equal to 0, I've got this, then I've got cos of, because the 1/3 is going to get multiplied here, all right, so what I'm saying basically from the Moivre theorem again, so that z power n could be equal to r to the power of n into cos of n theta plus I sine of n theta. So the n gets multiplied by the angle inside plus the 2k pi. So now if I have to multiply 5 over 6 pi, okay, by 1/3, okay, because this is, we multiply by n and it's 1/3, I'm going to get 5 pi upon 18. So that's cos of 5 pi upon 18 plus I sine of 5 pi upon 18. So that's my first answer. So if I were to simplify this, this is going to become 6, and then I've got cos 5 pi upon 18 plus and all of that in brackets, I sine of 5 pi upon 18. And what about my second angle? The second angle, so I'm going to say this is Z1, and my second complex number Z2 is going to be equal to 6 into cos of what's the second angle? The second angle is when k is equal to 1. So if k is equal to 1, what am I saying? I'm saying that the angle when k is equal to 1 is going to be equal to 5 pi upon 6 plus 2k pi. So 2 times 1 times plus 2 pi. And then all of that gets multiplied by 1/3. So 6 times 2 is 12, 12 plus 5 is 17, 17 pi over 6 times 3 is 18. So the next angle is 17 pi over 18. Immediately I can see a sequence of angles over here. So I can see the difference between these two angles is 12. So the next one's going to, of course, be Z3 is equal to 6 into, just to cut it short, cos of, if I have to add 12 here, so that's 29 over 18 pi plus I sine of 29 over 18 multiplied by pi. And of course, if you're in doubts here, you can check it out by just putting k is equal to 2. And if you were to do this, let's try and check this out if it checks out. So if when k is equal to 2, I'm going to get 5 pi over 6 plus 2 times, now the k is 2, so 2 times 2, 4, so plus 4 pi, then all of that gets multiplied by 1/3. So of course now 4 times this is 24, 24 plus 5 is 29, so we're getting 29 pi over 3 times 6, 18, checks out over here. So these are the three roots of that complex number in the form that was required, that is in the form of r into cos of theta plus I sine of theta. Take care.